Hi friends, welcome to the Unit R Day 5 video. This one's jumping into example 3, and this is finding the sum or difference. So we talked about multiplication and division with rational expressions. Now we're going to add and subtract them. Before you can add and subtract anything that's rational, remember rational means a fraction, they have to have the same denominator. So looking at number 5, they do not have the same denominator. They're not both 25x squared or 10x. So what you want to do is you want to find the factors of everything. So in this case, we're going to factor 10x, and we're going to factor it completely. So if I factor 10x, I get 2 times 5 times x. Again, if you need to make a factor tree for 10 to help you, you can do so. And then 25x squared, I'm going to get 5 times 5, or 5 squared, and then x squared. And I'm actually going to list these out, each of the individual pieces, instead of actually writing it out as 5 squared and then x squared. That's what I would do normally. Just so you can see, we're trying to essentially multiply. What we can do is we can multiply. Whenever we multiply, we want to multiply, whenever we multiply a side, we want to multiply it by 1. Multiplying by 1 does not change the number. So looking at what we have here, we need to make sure that we're looking to see what we need to multiply each side by, that each side is then the other side has. So I'll refer to this as, what each side is missing. So if I look on this side has a 2, a 5, and an x. If I look over here on this side, out of this set here, it's missing a 2. So I'm going to need to multiply this other side, the right-hand side, by a 2. Whenever we multiply something by 2, we can't just multiply the numerator or just the denominator. We have to multiply both. Remember, we're trying to multiply by 1. So if we multiply by the same number, over the same number, that's multiplying by what I call the convenient form of 1. So I multiply the right-hand side, so I'm going to have to multiply. I'm going to be including a 2. So what I'm going to do is I'm going to kind of set this up off to the side and just kind of note, and I'm using a different color to note this. So I need to multiply the right-hand side by a 2. So I actually, let's go ahead and set it up this way. So left and then right. So the right-hand side is missing a 2. And then it looks like the left-hand side, I have a 5 and an x, but I'm missing another 5 and another x. So I'm going to have to multiply the left-hand side by a 5x. So now that I have that kind of denoted or figured out, what I can do is set up this problem. So here I have 7 over 2 times 5 times x. I'm multiplying this by 5x over 5x. 5x over 5x. Plus 3 over 5 times 5 times x times x. And I'm multiplying this side by 2 over 2. So now what we have when I multiply this through is I should end up with the same denominators. Again, that was our goal. We need to have common denominators to be able to combine these together. So 7 times 5x, when we multiply fractions, we multiply across. So 7 times 5x is 35x. And then my denominator, 2 times 5 times 5. So 2 times 5 is 25. 25 times 5 is 50? No, that's not right. 5 times 5. 2 times 5 is 10. 10 times 5. I was like, it should be 50. Having a day. So 50, and then x times x is x squared. So I should have 50x squared as my denominator for the other one as well. 3 times 2 is 6. 5 times 5 is 25. Times 2 is 50. X times x is x squared. There we go. I was concerned there for a moment. Now that I have the same denominators, I can combine them. So I have 35x plus 6 all over 50x squared. We talked about this previous set of notes, but I can't have x. X cannot be 0. Because if it's 0, then I'm dividing by 0. So there's 5, and then 6. Again, we need to have the same denominators, so I'm going to go ahead and find the factors of my denominators. This one is x plus 3 and x minus 3, where the other one's just an x minus 3. So I need to multiply the left-hand side by nothing. It's already there. It already has what the other side has. But I need to multiply the right-hand side by an x plus 3. So now when I go through and do that, when I set this up, I have 10x over x plus 3, x minus 3 over here. And then I'm not multiplying anything over here, so that can stay as it is. And then minus. Now this is where it gets interesting because of this minus sign. So actually what I'm going to do is I'm going to change this minus sign into a plus. And I'm going to put a negative symbol in front of the 5. That will help with what's going to happen here next. Oh, and then I can go ahead and put in x minus 3 in my denominator here. So I'm multiplying this by, in parentheses, x plus 3 over x plus 3. I said that we need to keep track of this because of this negative sign. When we multiply it through to this x plus 3, when we distribute it, it gets to both. I'm going to be multiplying it to both. So that's going to change the value here. So now I can combine. I have got 10x over, these have the same pieces, so I'm going to combine it over the same denominator. So x plus 3 and x minus 3. And then what I have here is distributing this negative 5 to x, so minus 5x, and distributing negative 5 to the 3, so minus 15. And now I can combine like terms. In my numerator, 10x minus 5x is 5x. So I have 5x minus 15 over x plus 3 and x minus 3. Again, seeing this 5x minus 15, that's factorable. So let's go ahead and factor out a 5 from both of those. So if I do that, I'm left with, did not leave myself enough room, I apologize. I'm left with 5 and then x minus 3 over x plus 3, x minus 3. Now you see, oh, I can eliminate. So we go ahead and do that. So I have a 5 over x plus 3. Again, my values that I cannot have. I cannot have x being negative 3 or positive 3. So minus 3. We'll talk about that. Again, I'm giving you these values now so that you can see how they come into play soon. Join me as we finish out example 3 in the next video.